Recursive rules for sequences. This is the last unit or the last section for this unit 10.3b it goes with. So we're going to look at writing explicit and recursive rules. So recursive rules are going to be new. Remember that an explicit rule is what you've been doing so far. It gives a sub n as a function of terms in position n in the sequence. Those are our a sub n equals dn plus a sub 0 for arithmetic, or a sub n equals a sub 1 times r to the n minus 1. So those are our explicit rules. They can give us any position n in the sequence. Like if we want the 8th term, the 100th term, etc., we'll use that rule. A recursive rule gives the beginning terms and the equation that tells us how a sub n is related to the previous term. So we will have to use a sub n minus 1, so remember that that means the previous term. So a recursive form for geometric series is, the formula is a sub 1 equals, so you have to give the first term, and then it's a sub 1 is the previous term times r. So for example, number 1 here, 2, 8, 32, 128, we're multiplying each term by 4. So that means our r equals 4. So my recursive formula would be, I have to first tell you what the first term is, a sub 1 equals 2. Then, for my a sub n, you just take the previous term times 4. So you take the previous term times 4. And we typically write that as the 4 out front, because that's like our coefficient. So 4 times the previous term. So you just get the next term by multiplying the previous one by 4. In the second example, from 9 to 3, we're dividing by 3. So remember, that's going to be the same thing as multiplying by 1/3. So I'll tell you the first term is 2. And then you get the next term by taking 1/3 times the previous term. So 1/3 times a sub n minus 1. And they're very nice to work with. They're easy rules, except for that if you wanted to find the 100th term, you would have to first find the first 99 terms. So that's the only thing about recursive forms, is it's not good for finding large terms or terms far in the sequence. It's just finding them in order. So you have to find them in order using a recursive rule. So in order to use it, you have to know the first term. So a sub 1 equals -2. Then it says that the next term is -3 times the previous term. So you just take, to find a sub 2, you take -3 times the term before it, which was -2. So you'd have 6 for the next term. And then to find the third term, you take -3 times the previous term, which was 6, so you get -18. The fourth term would be -3 times -18, the previous term. Should be 54. The fifth term would be -3 times the previous term, or -3 times 54, which is -162. So it's really that simple. Over here, it's the first term is 4, and then it's 2 times the previous term. So you're just multiplying the term before it by 2. So 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64. So recursive rules are really easy to use. You just use the previous term, but you have to go in order. So let's compare the two rules. Write a rule for the geometric sequence. So an explicit rule is a sub n is a sub 1 times r to the n minus 1. And the recursive rule is this one. You have the previous term, or the first term. You have to state that. So the first term is 4. And then you find the next term by taking the r, so 0.2 times the previous term. So it might look like that. But the first term has to be included in your rule. So that's part of your answer, essentially. Over here, you have the first term is 4, and then it's r 0.2 to the n minus 1 power. So this is your explicit rule. So in the explicit rule, I could find any term I wanted. I could find the 100th term, or I could find the 1000th term. But in the recursive rule, I would have to go, the terms have to go in order. Oops, I didn't mean to open that. So you have to oops, why do I keep hitting that? I'm sorry, hold on. All right, I'm just gonna move on. Go in order. Okay. The explicit rule would be a sub n equals a sub 1 times r to the n minus 1. The recursive rule would be, oh my goodness, I need to move this. I keep hitting that. The recursive rule, you have to first tell me what the first term is. Then the next term in the sequence would take the r times the previous term. So there's your recursive rule. Okay, how about a recursive rule for an arithmetic series? So for arithmetic, instead of multiplying by something every time, you're adding something every time. So this would be the rule here for arithmetic. You still need to tell me the first term, but then it's the previous term plus d. Remember, d is the common difference. A sub 1 is the first term, and a sub n minus 1 is the previous term. So 7 plus 4 is 11, 11 plus 4 is 15, 15 plus 4 is 19. So if I wanted to write a recursive rule, I would first have to tell you that you need to start at 7, so the first term is 7. And then you take the previous term and you add 4 to it. So that would be my recursive rule. So I could find the next term would be 23. After that, it would be 27. Here, 7 halves, 3 halves, negative 1 half. Remember, when you are adding or subtracting fractions, you're looking at the numerators. So 7 to 3 is subtracting 4. So it looks like I'm subtracting 4 over 2 here. Subtracting 4 over 2. And 4 over 2 simplifies to just negative 2. I don't know why that keeps popping up here. So D will be negative 2. So I need to tell you my first term is 7 over 2. And then to find the next term, you take the previous term and you subtract 2. So that would be the recursive rule for that. Using a recursive rule for an arithmetic series, you have to know your first term. So my first term is negative 2. And this rule says take the previous term and subtract 10. So negative 2 minus 10 would be negative 12. Negative 12 minus 10 would be negative 22. Negative 22 minus 10 would be negative 32. And negative 32 minus 10 would be negative 42. So just working in order. Here I want to add 5, so I start with 4, plus 5 is 9, then plus 5 is 14, plus 5 is 19, plus 5 is 24. So essentially you're looking at the previous term plus 5, but you do need to know where to begin. Let's just practice writing an arithmetic series in an explicit rule and a recursive rule, and then we'll be done. So a sub n for explicit rule is dn plus a sub 0. Recursive rule is the first term is negative 7, and then the next term you have to take the previous term plus your d, so plus 3. So the recursive rule tells me to add 3 to my previous term. In explicit rule, I do have to find a sub 0. So if I'm adding 3 every time, take negative 7 and subtract 3, a sub 0 will be negative 10. So my explicit rule would be a sub n would be 3n minus 10. So again, an explicit rule, I could find the 100th term easily by just plugging in 100. So 300 minus 10 would be 290. The 100th term would be 290. In order to find the 100th term over here, I'd have to find the first 99 terms first. I have to go in order. And so it would take a long time to find the 100th term. I'd have to know the 99th term first. So there's times and places to use explicit rules and recursive rules. So if you know that you can go in order, then that would be fine to use a recursive rule, but otherwise you'd want to use a explicit rule. Okay, I think I'm going to call it on the video. I covered what recursive rules are. There are a few more examples in the notes, which you could find on Schoology if you wanted to finish out your notes for the day. That's all I got.